Hi, today's topic for discussion is radiograph interpretation of welds. In addition to producing high-quality radiographs, the radiographer must also be skilled in radiographic interpretation. Interpretation of radiographs takes place in 3 basic steps: 1. Detection, 2. Interpretation, and 3. Evaluation. All of these steps make use of the radiographer's visual acuity. Visual acuity is the ability to resolve a spatial pattern in an image. The ability of an individual to detect discontinuities in radiography is also affected by the lighting condition in the place of viewing, and the experience level for recognizing various features in the image. The following material was developed to help students develop an understanding of the types of defects found in weldments and how they appear in a radiograph. Porosity is the result of gas entrapment in the solidifying metal. Porosity can take many shapes on a radiograph but often appears as dark round or irregular spots or specks appearing singularly, in clusters, or in rows. Sometimes, porosity is elongated and may appear to have a tail. This is the result of gas attempting to escape while the metal is still in a liquid state and is called wormhole porosity. All porosity is a void in the material and it will have a higher radiographic density than the surrounding area. Offset or mismatch are terms associated with a condition where 2 pieces being welded together are not properly aligned. The radiographic image shows a noticeable difference in density between the 2 pieces. The difference in density is caused by the difference in material thickness. The dark, straight line is caused by the failure of the weld metal to fuse with the land area. Incomplete penetration (IP) or lack of penetration (MOP) occurs when the weld metal fails to penetrate the joint. It is one of the most objectionable weld discontinuities. Lack of penetration allows a natural stress riser from which a crack may propagate. The appearance on a radiograph is a dark area with well-defined, straight edges that follows the land or root face down the center of the weldment. Slag inclusions are non-metallic solid material entrapped in weld metal or between weld and base metal. In a radiograph, dark, jagged asymmetrical shapes within the weld or along the weld joint areas are indicative of slag inclusions. Cracks are thin, straight or jagged, linearly disposed discontinuities that occur after the melt has solidified. They generally appear singly and originate at casting surfaces. Cracks can be detected in a radiograph only when they are propagating in a direction that produces a change in thickness that is parallel to the X-ray beam. Cracks will appear as jagged and often very faint irregular lines. Cracks can sometimes appear as tails, on inclusions or porosity. Excess weld reinforcement is an area of a weld that has weld metal added in excess of that specified by engineering drawings and codes. The appearance on a radiograph is a localized, lighter area in the weld. A visual inspection will easily determine if the weld reinforcement is in excess of that specified by the engineering requirements. Inadequate weld reinforcement is an area of a weld where the thickness of weld metal deposited is less than the thickness of the base material. It is very easy to determine by radiograph if the weld has inadequate reinforcement, because the image density in the area of suspected inadequacy will be higher darker than the image density of the surrounding base material. Tungsten inclusions. Tungsten is a brittle and inherently dense material used in the electrode. In tungsten inert gas welding, if improper welding procedures are used, tungsten may be entrapped in the weld. Radiographically, tungsten is more dense than aluminum or steel, therefore it shows up as a lighter area with a distinct outline on the radiograph. Burn-through results when too much heat causes excessive weld metal to penetrate the weld zone. Often lumps of metal sag through the weld, creating a thick globular condition on the back of the weld. These globs of metal are referred to as icicles. On a radiograph, burn-through appears as dark spots, which are often surrounded by light globular areas, icicles. Cold lap is a condition where the weld filler metal does not properly fuse with the base metal or the previous weld pass material, interpass cold lap. The arc does not melt the base metal sufficiently and causes the slightly molten puddle to flow into the base material without bonding. Cluster porosity is caused when flux-coated electrodes are contaminated with moisture. The moisture turns into a gas when heated and becomes trapped in the weld during the welding process. Cluster porosity appear just like regular porosity in the radiograph, but the indications will be grouped close together. Incomplete fusion is a condition where the weld filler metal does not properly fuse with the base metal. Appearance on radiograph usually appears as a dark line or lines oriented in the direction of the weld seam along the weld preparation or joining area. Multiple international organizations and committees endeavor to standardize